occurrence of rockburst can cause the extra cost to mining companies. And so the guidance is needed. What time period is focused on the tunnel direction as detection, and how did some factors affect the occurrence of rockburst related to time. And this is a precondition of a rockburst. So after we excavate the tunnel, the detonation wave can, in blasting, will result in defect of the initial crack in the intact rock sideways and here, and the stress, because of the gravity of the rock, the stress will redistribute after the excavation, and as we see here, there will be extra stress on the side wall, and the cracks will develop under the compression. And some rough idea at the very beginning is that the deeper the tunnel is, the harder the rock and brittle the rock is, there will be higher chances for the rock burst to occur. And most of the rock burst is occurred in the non-structural area, and there's some particular rock property which will have much higher chances to have a rock burst, such like granite and dorite. And I studied 12 12 sites, and about their recorded rock burst. And after the excavation, we can see it seems the rock burst occurrence follows some particular pattern, such as the first 1 month, especially in the first 24 hours. And also, there's some particular cases which is cannot be really which happened even after 12 months of excavation. There's still some rock burst, so we need to study on it to see the time effect of the rock burst. So the literature review and the formulas that I've been using is about this. So some of the factors that we can immediately think of is like, for example, the rock providing a specific depth and the rock density, which determines the lateral and the vertical crest and the tunnel shapes. These are the factors that we need to concern and might have an effect on the occurrence of rock burst. And after here, we make some assumptions to find out a way to work out probably a formula of a rock burst. And I assume, because of the studies, I assume that the depth of the tunnel is like 1,000 meters. Then the parameter of the rock property mainly is like density and the C and the N. Here are the parameter of several rocks, dorite, granite, and sandstone, in which rock field there will be higher chances for rock burst. So here in my studies, I assume that the rock property is like a pretty intact granite, and the density and the C is like this, and the variant of N will be 1, 2, and 3, and 4. And for the crack depth, initial crack depth, I use because of here, it will be from a few millimeters to several centimeters. So I will use 3 of it, which is the 0.005, 0.02, and 1, 0.1 meters, and the angle between the crack and the vertical direction is the 10, 30, and 50, and this one I use the letter L, which is the distance between the initial crack to the side wall. I use 0.1, 0.5, and 1, and up to now we will put up the question that do those factors affect the growth of a crack in respect of time, and how did they affect it? Can we draw a formula with all those factors, and so that the time the rock burst occur can be largely predicted, and the sufficient prevention and reinforcement can be taken before the rock burst occur. The method of this study is mainly literature review, theoretical conclusion, including dimensional analysis and data analysis. Here is my calculation, just theoretically, and here to get rid of the unit trouble of C, to dimensional, I make it dimensionless, and get this one. And finally, we get a conclusion, which is here. This is going to be input into the MATLAB as a code. So as a result, the input of NL A alpha, which is 4 times 3 times 3 times 3, which is 108 cases, as will be recorded. Then, so there will be different types of plots. The first one is pretty random and is not very make no sense. It's like this. So in this case, I will consider the rock burst will not have take place. And the second type, actually these are pretty much the same. It's like the distance according to time is just always increase and gradually. And this for this one is like here is the when r equals to when r is beyond the 0.85% of L, which can be regarded as the rock burst could happen. And this one is like the most normal, and is by the time of 10 powered by 7 seconds, it is still far away from the criteria. And for some cases like this is before the calculated time. It's the R has ready rock burst that will be regarded as abrupt rock burst will take place. And considering the effect of N, here are the calculation, the summarize in Excel. We can see that the green one means it's pretty safe, which is related to this case, and the white one, which is not marked, matches with this case. Sorry, which is also very safe, and the yellow related to this one, which is a stable or not non-abrupt rock burst could take place, and the red one that means matches with this one, this pattern, which is rock burst is pretty likely to happen, and this purple one means actually at the very early beginning, the initial crack length has already been beyond the criteria, which is the more than 85% of the R. So the effect of, to consider of the effect of N, actually all of these 108 cases, because the variance is have 4, so it's pretty difficult to draw it in a particular shape. So most of it, when the rock burst is not happening, there's no abrupt rock burst happening, which is like this case, and we can see a particular pattern. It's pretty obvious that when N is 1, 2, 3, 4, that means by this time, the crack length when N equals to 1 is the highest. That means the rate of crack growth when N equals to 1 is the highest. So the rest, the others, these two pretty much the same conclusion. That is, when the L, A, and alpha is given, when A equals to 1 is like this case is mostly for the rock burst to happen. However, when the A is big enough, initial crack length is big enough, and the alpha is small enough, for example, when it's 10 or 30, it might be complex. So when N equals 3 and 4, the rock burst is roughly less likely to occur than when it was 1 and 2. And for most of the cases, the higher value of N is, the slower the crack grows. And when the crack is relatively long, and when the distance to the wall is short, and the angle between the pole and the vertical direction is followed in this range is pretty rough. The previous rule does not follow, is not fully applicable. And the next factor, which is L, it shows a pretty obvious pattern, which is the the bigger, we can see from here, here is the length, which is the crack, initial crack is the shortest to the side wall. So we can see it is pretty obvious that from almost all the cases, the higher value of L, the slower the crack grows, by which time the crack length is relatively short. So, and the shorter distance to the wall, the greater influence of I. So, for example, the difference between L equals to when L equals to 2 and when L equals to 10 is actually pretty much the same. However, from L equals to 0.1 to L become 1.105 actually is pretty obvious. And the effect of A, which is the initial crack length, is also pretty obvious. Here I did some extra calculation in more cases, so we can pretty much get the conclusion that with a given n other factors, the bigger the crack is, initial crack is, the faster the crack will grow. And the final factor, which is alpha in the study, actually is the most difficult one, and my conclusion is generally like there's no pattern how with the increasing alpha, the rate of the growing rate of the R is pretty random. Like we can see from 40 from 10s to 15 to 25 to 30 to 35 to 40. Yeah, it's pretty random. There's no obvious conclusion. Yeah, no clear pattern or trend of crack growth. Our crack length with T has been demonstrated with the alpha increased by 5 from 10 to 50. However, if we take a look at the Excel, actually we can still find some of it. When it is generally stable, which I mentioned before, it's like when n equals to 3 and 4, it's mostly there won't be any chances for rockburst within the time. Among the 3 value, which is 10, 30, 50, when alpha equals to 50, the crack growth always the slowest. So we can see the same time, this number when alpha equals to 50 is always smaller than the previous two. Yeah, 0.02, 0.03, 0.04, 0.005, 0.007, 0.009. Yeah, and when it is more active, which is when n equals to 1 and 2, among the 3 value of alpha, when alpha equals to 30, actually it could be, it's pretty, also roughly, the crack grows the fastest among the 3. Like here, when alpha equals to 30, the crack length by the end of the calculated time is 0.9. The rest 2 is 0.3 and 0.6, and such as this one, 0.2, bigger than 0.1 and 0.08. And take a bigger range of alpha, providing the other 3 factors the same. It also shows no pattern of how alpha gonna affect the effect of other factors. For example, from these 3 pictures, as alpha grows, it seems that it enlarges the influence of L. However, if we take a look at this one, which is 36, it does not follow the same pattern. Like the natural growth of alpha will result in any kind of pattern of other factors. So the application importance is after the excavation is completed in mining. So a very rough assessment of stability of the cycle can be made to predict whether that is safe or not, and when the rockburst could happen. And in the most likely, it's like a rockburst active area, sufficient ground support or reinforcement can be done in time to avoid personnel or property losses. And limitation of this study and the conclusion is that rock are actually not always homogeneous, and there's pretty everywhere in the real production is different, and the formula used in the calculation is the axial compression, and the PZ in the real world is not a constant load, and the measurement of the rock property, which is C, N, and K1C, it is very difficult to be accurately measured, and it is very difficult to avoid errors in the measure of the initial crack properties of inside the lateral rock mass beneath the side wall, and the shape, especially the shape of the initial crack, may not just be a pore. It could be pretty complex after the deformation wave. And during the crack growth, the calculation didn't take into account of the interreaction or correlationship or effect between different cracks. So the result and conclusion is like with sufficient and accurate input of D, rho, C, N, L, A, alpha, and reasonably delta T, so that they are, which is a crack length, and at a particular time can be roughly predicted, or we can say that T at a time when R equals to 85% of L can be predicted, which is the time that a rockburst is likely to happen. And all of these factors could have a effect, have an effect on the correlationship between R and T. And the pretty general idea of this factor is like as the L grows, the R at the end of the calculated time will decrease. And when A is increasing, the R at the end will increase. And these two show a clear pattern. And the rest two is pretty rough idea, and they have to be applied to the conditions. And the future work, if we want to make this prediction, make this tool more applicable, it's like a more comprehensive code needs to be written in the program. And at the same time, the program should be able to connect it to some real-time detection hardware and or devices. So the software can update its input in real time. And the more statistics such as the average crack length and the average impact between cracks need to be measured and corrected in the formula in the existing program. And thank you for watching and your time. Thank you very much.
Good questions?
Yes, I'm sorry, but I did get lost a bit. But hopefully you can help me clarify a few
sure.
things. So,
I'll try my best.
Okay, thank you. First of all, can you go back to your just I forgot which page. Can you just scroll back a bit?
Yeah.
All right. Yeah, if you go back to the handwritten equations. I mean, first of all, I have to say, my knowledge in this area is pretty thin. Can you, so on page 18, this is, this is. Can you just explain to me a bit further, what you're trying to establish here?
Yeah. So this one is the K1, which is pretty much given formula, and here this F.
Yeah, but what's K1 represent? What's the different letters?
Okay. The F is like the force, lateral force, vertical force, and R is the. Do I have a picture? Okay. All right. So suppose this is the tunnel, and the D represents the distance from the tunnel to the surface, which is 1,000 meters. This is like depth to the surface, and which is here. And rho is like the density of the rock. G is just gravity. PZ, so this three factors times together is like the lateral stress. The vertical stress.
Yes.
And F is like a calculation of the force, presenting on this. And this alpha is like for example, here is the defect, and this is the vertical. Here is a pole, and alpha is the the angle between this this pole and the lateral,
Okay.
sorry, not lateral, I'm not saying that, vertical distance, this angle, and K1C is like the critical K1, and time is just time, and C here is just a calculation. C is just C and N are the factors in the charge law, which is pretty determined by the property of the rock. That's that we take a sample of the rock in that field to determine C and N. But however, it's difficult to be pretty accurate to in situ.
And R is the correct.
Correct length.
Yes, yes.
Yeah, A is the, where's A? Yeah, here this one is A. A is like the initial crack length of the pore. For example,
Okay.
yeah, the R radius of the initial one, and as this pore under the redistributed stress, it will in length. So at the T0, which we just start to calculate, the R, which is crack length, equals to A.
Yep. Okay. All right. I don't think we have time to explain this
Sure.
one by one, but I just wonder. So A is your
Initial crack.
Yeah, it's your
Yes.
input. So how do you find that A in reality?
Yeah, here is it is pretty estimated.
Okay.
Yeah, as the reading from the papers
Yeah.
after the crack length, crack size after excavation at the excavation surface. It's like after the blasting, there will be some research on general, like average crack length done by the denudation and blasting.
Yeah.
So actually, it is pretty rough. So this is from few millimeters to centimeters. So I just use all of it. So if we want to use this formula to predict, we need to probably some more advanced tools to detect like the size of the pore.
Yeah. So actually on that, because your input has uncertainty, that means your output should also have uncertainty there.
Yeah.
And maybe there's something good to present. What's the upper bound and what's the lower bound and what's the best estimate?
Yeah.
Yeah. So maybe there's something you could consider.
Yeah.
And my next question is, you have done lots of like more than 100 calculations.
Yeah.
Is there any like physical experience that you can compare with?
This one, can you explain again? What is that?
Yeah.
Compare
So
what?
this process using this my understanding this is more like an analytical solution. Have people done any laboratory testing
For this one?
Yeah.
Oh.
Or numerical simulation in published papers?
Yeah, I think there is someone who already done this research.
Yeah.
Also, if they draw the same pattern, which is like is this shape, it generally.
Yeah. Does are you able to compare your prediction with those published or?
I think probably I can. But of course not now. I should.
Yeah. So
Yeah.
because you still have maybe like 2 or 3 weeks.
Okay.
Maybe just provide 1 or 2 comparisons.
Yeah.
Just to
The existing research result.
So that's just establishing link with the existing knowledge.
Okay.
People would be really happy to see that before you present further results. Yeah.
Okay.
And also, I think you presented lots of tables, Excel tables,
Yeah.
and they not the most efficient way to communicate the results. Do you think you can convert this into any chart or?
Yeah, I also want actually to consult because it's like a 1, 2, 3, 4.
Yeah.
I actually don't know how to like present it in yeah.
Yeah, I also like the MATLAB files. I'm not sure what function they're serving on this.
Okay. Yeah.
Yeah, and also on this, this is just my suggestion about your presentation.
Okay.
So, is R a dimensional parameter or non-dimensional?
It is non. It is dimensional.
Dimensional. Okay.
Yeah.
So, what's the unit?
The unit of R is just meter.
Okay.
The crack length.
It's missing, right?
Oh, it is in a MATLAB.
No, but when you show a figure to people,
Okay.
the label actually is very important. Yeah.
Okay. Okay.
So there's
Yeah.
a bracket, meter,
Yeah.
and then T is second, as I understand. So that probably should also be labeled.
Okay.
Yeah. So
yeah.
as engineers, when we present data,
Yeah.
if it's dimensional, we want to give people that dimension.
Yes.
Yeah.
Yeah.
Yes, and the other thing is you said the alpha effect. It seems
Yeah.
there is no trend, but you did say it's random. But actually, when you say it's random, that means your input is very sensitive to the input. Is it just no trend or is random?
I should say it's not purely random. Maybe I should use another word in English. I mean, like, for example, which is different to like the size of A. When A increase from a value to the other value, which is the crack length, initial crack length, the rate of growing of R is very obvious when A, like at the end. We can say that with initial crack, lateral grown bigger, the rate of the crack.
The trend is very clear, but for alpha, it's not clear, right?
Yeah, when alpha is increasing, for example, from 10 to 50.
So my true question is,
Yeah.
are you able to offer any explanation why it's that way?
I think about it for a little bit, but honestly, I didn't research on that. Why it is that? I think it's probably some physical things. It's like when we are considering the vertical press, when it's like this, it is actually easier for the crack to grow. But with this direction,
can you link back to the alpha value you were looking at? You go back to the page. This page.
Yeah.
So let's say what's 40? How do you
40?
Yeah.
40 and 35 will be
40 and 45. 40 is the bottom, 45 is the top.
Yeah, 40 and 35. These two, that I would consider it as it will not really, result in a rockburst.
Yeah, because it's reducing.
Yeah, it's reducing.
Yeah.
However, from let's say 10 to 15, which is this two line, this light blue line and this orange line, the direction of the pole is from here to here.
Yeah.
Then that means from here, it is from this angle to this angle, from 10 to 15, the rate of the crack growth increase. However, just from
Actually, I just noticed your R goes to negative.
Yeah, that means
Print. Now, your angle sign in degrees, and 40 is 40 degrees.
Yeah, 40 degrees from alpha equals to
And
40
in
degrees.
MATLAB you set 40.
Yeah. So,
In
if it's
MATLAB, sine and cosine, angles should be in radians. Between 40 and 35, you have 5, which is close to 2 pi. That's why you change the sign. That's why you want relative.
So we need to be very careful.
oh my god. Yeah, okay, I will go back and change it. So I should input for example, if I want to input as 45, I should pi divided by 4.
Another thing, 10 to the power 7
Yes.
is an arbitrarily chosen way. In fact, in all circumstances,
Mhm.
your radius tends in eventually tends to infinity. It is like that.
Yeah. Yeah.
In all cases, you need just to wait
Mm.
to increase the time until you've got that and fix that time and record that time.
Okay.
So
Yeah.
this is the time when the rockburst will happen.
Yeah.
Now, if you return to your plots where you have this vertical, this one. If you just take the first plot and cut
Mm.
and say that show arc,
This part probably is just be like here.
yes.
Yeah.
So it's always like that. It is an
Yeah.
asymptote.
Yeah.
Asymptote. And that it is what you have to find. You have to find the time when it becomes infinite.
Will there be some cases that the time is pretty long?
No.
No? Oh.
So maybe you can compare with the project lifetime.
Yeah.
If the project lifetime is a few years,
Yeah.
maybe you gave it like 3 times of the project time
Yeah.
life,
Yeah.
then maybe that's a reasonable.
Maybe.
Yeah.
Yes, maybe.
Yeah. The reason why I use this number, this is roughly 3 years, which is compared with the recorded last.
It's 3 years.
Yeah.
Yeah.
Yeah. So yeah, I could do that. In my final report, I will.
Yeah. So if you make it years, it make more sense to people. So 10 to the power 7 seconds.
Okay.
I have no
It's
idea.
hard. It's hard.
Yeah.
Okay. Yeah.
Yeah. And back to the previous page, the alpha equal to negative value is something you need to check. Because
Yeah. There's some.
basically that's not possible.
Yeah.
Yeah.
Actually, there's more cases. When I mention NA, when I record NA, that means the shape is always like, for example, this is 0. Sometimes it will go down and up, which is this part, which is below 0, is pretty unrealistic. And sometimes in this shape, which is also unrealistic.
That's right. So when you see those features,
Yeah.
the best way is to bring it to academy and have a discussion. You found this feature. You don't want to just leave it there and present and say, oh, this is what the MATLAB code gave me. You want to understand what, there was something happened. Is that physical or is that just numerical? Is there something wrong in the code or something we did not consider? I see you describe lots of your data, but you say very little about the physical process. Because I still don't understand what's really going on in some of the results. So that's where you probably want to put a bit effort in when you write your final thesis.
Okay.
I can see you have done a very large volume of work, but the understanding probably still should be improved.
Okay.
Yeah, that's my overall comment.
Yeah.
Yeah, that's all my question. Thank you.
Okay.
Yeah. Yeah, but it is quite interesting work. Quite practical. There's lots of applications.
Yeah.
Yeah. And when you finish your work, you get a job. You will need to explain to people the true physics. Yeah.
Excuse me. What is true physics? It's like how.
Yeah, you need to. For example, you see a trend.
Yeah.
You don't just tell people it's increasing or it's decreasing. You will say this is increasing or decreasing because. Yeah.
Okay.
Yeah. Because we try to understand what's happening. Yeah.
Okay.
Yeah.
It's like more detailed explanation of the mechanics instead of just this is the numerical conclusion.
Yeah. So if you understand what's going on, then people will have confidence with what you say. Yeah.
Okay. Yeah. Sure.
Okay.
Thank you.
Thank you.
Yeah. Definitely no negative R in your final thesis. All right.